Greetings, students. This is the lecturer, Mr. Ramnath, and I will demonstrate how to solve the problem. It's a mass spring damper, critically damped with zeta is equal to 1. This is the equation. Find x0, v0, and omega 0 if you're supplied with the time, the displacement, and the velocity. So, start off from the equation. Write the equation over there. Rewrite it in that form. Substitute a value of t1, t2, and t3. You have these equations. From the first equation, solve for x0. Get a formula. Put the formula for x0 into the second equation and then solve for v0. So you have the formula for x0 and you put it into the equation, you get a result for v0. And then substitute the previous result for x0 and v0, and then you'll have a formula in omega n, and then you can solve that formula for omega n by considering it as a nonlinear equation. So the algorithm is we'll pick a value for omega n from a minimum to a maximum. Of course, we'll pick a time 1, a time 2, a time 3, and the x1 and the x2 and the x3. We'll put that into the equations with these substitutions: alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3. We'll then put that into an equation. We'll plot the graph of omega n versus f of omega n, and where the root is f of omega n is equal to 0, that will be the answer for omega n. So let's go ahead and do it. Taking the first point, then I'll take a middle point somewhere. I've taken a point near the lower end of the time and the corresponding x1, a point somewhere in the middle, and a point right at the end. So I don't know the range of the values. I'm just going to say minimum value is 1, value is 10. I am going to take let's just say 200. this is a column vector. So I've done the substitutions. Now I want to calculate f. So beta 3 is a vector. I'm multiplying by a scalar. And when I want to do division of one vector by another vector, I use the dot slash. And when I want to multiply a vector by a vector, I use the dot star. Okay. Then when I don't have enough space, I'm just going to put 3 dots. 1, 2, 3. I press enter, so I'm on another line. Then I'll say minus 3 minus P1 alpha 1. Now this is a vector. I want to times it by another vector. Now I want to plot a graph of omega n versus f. So I want to see where it's 0. So obviously 10 is too big, so it's somewhere between 1 and 8. going to put 1,000 points. And I'll just work out the alphas and the betas again. Okay, so I've regenerated the data. Now I want to plot the graph again. So we see it's not very clear, but we know it's between 1 and 5. So it's definitely not between 5 and 8. So let's just try and do that again. And regenerate the alphas and the betas. Data is complete. We'll plot it again. So it's slightly positive. It's around 3, and then it goes negative. So as far as we can tell, it's the 0 is between 2 and 4. We'll search again now between 2 and 4. It is complete. Graph again. It seems that we are closer, um, but our resolution is from 2 to 4 every 1,000 points. So we can work out omega n to 0.2 times 10 to the minus 3. In other words, 0.002. So what should we do? Um, we can search again from 2.5 to 3.5. So it's slightly above 3 point something. So let us try and search from 2.8 to 3.2. Graph again. I'm just using the up and down arrow keys on the keyboard to toggle between the commands. Right, so there appears to be enough points. I'm just going to interpolate. So usually you interpolate an x against a y, but we want to interpolate where it is 0. So we'll interpolate with the y against the x. So we will say omega n is equal to interpolate 1 f wn at 0. So we're interpolating with the f values against the omega n values, where the f is 0, and that is basically searching for the root. That's our answer for omega n. And then, of course, we want to work out the v0 with that formula. Apply the formula. So the numerator is exponent, all of that, that's on the top. The denominator is at the bottom. That's the velocity. And then we'll just use the formula for x0. That's the answers. So answers are omega n, x0, and v0. Okay, and that is the end of the presentation. So find x0, v0, omega n from the times, the x's, and the v's. Write the equation, rearrange the equation, substitute a time 1, a time 2, a time 3. From one equation, solve for x0. Take the formula for x0, put it into the second equation, solve for v0, and then use these two formulas into the third equation to get a nonlinear equation. Plot the graph of the nonlinear equation and find where it is 0, work out the omega n, back substitute into the v0, back substitute into the x0, and then that's the answer. So the key point is that GNU Octave has vector functions, so you can do vector operations with the dot operator. And that's about it. Thank you very much.